Recording has started. Hi all, welcome to the AIML Study Circle led by uh, Jaymeet Vasave of EOTF, and what we are doing is part of this weekly series. This is our fourth session. We had three sessions. In the first session, uh, Jaymeet had covered the fundamentals of AIML, that is artificial intelligence and machine learning, with the block diagram and all. And later on, we moved on to the second one where we had dealt with the use case with the pipeline for search, objects search, and the third one he did was for the what you call nameplate and uh, face recognition and suppression to maintain privacy. So today we are bringing the fourth one, and that is models for ML system design. So this is a journey where we started one with the broad view, then we narrowed down to two use cases. Now we are again going back to broader view, especially with center focus on models. So the algorithms and models is what we are going to uh, have presentation from Jaymeet. So with that, uh, Jaymeet, I will hand over to you, and I'll go into mute mode. You can share. Your share is seen on the screen. Only we have to hear your voice. Go ahead. Take care. Thanks. And we'll do Q&A at the end.
So, hello everyone. Welcome to the presentation for models for ML system design. And this is our fourth presentation, where we have discussed two use cases as well as also structures for common structure or a basic structure for ML system design. So for basic ML system, so this was the basic ML system outline that we have discussed in the very first presentation, where 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 we started discussing with date. Just where we started discussing about data collection, data verification, and all the stuff that was data related. The data will be then further prepared to be given as an input to the ML algorithm. So the ML algorithm will always be chosen based on the data that we have at hand and the kind of output that we want from the data that should be processed by the ML algorithm. So it is really important how we choose the ML algorithm. So we'll look at some of the right ways of choosing an ML category. So these are some of the basic ML categories. We have supervised learning, where the ML model learns from labeled data, and or we already know the output of it, and the ML model is trained to get to that output or give us the predicted out the predefined output that we already know. In supervised learning, we have binary and multi-class classifications in the classification, where where binary classification means, let's say we have an image of a dog. So the prediction should be whether it has a dog or not. And in multi-class classification, there are multiple objects. There are multiple objects present in the image, and we try to classify uh, as many of those objects present in the image or not. So that is multi-class classification. In regression, we try to predict a value, predict a continuous numeric value. Let's say example, predicting a value of house depending on the square foot area, the locality, and what grade the house is of. In unsupervised learning, the model learns without any human supervision, or it learns to recognize the patterns in data without any human supervision. In unsupervised learning, we have clustering, where the data points which has similar properties are grouped together in a cluster. In association, the association, the data points, sorry, the association between the data points are is created. So let's say we are trying to buy just only shop for breakfast. So first we buy milk, and further the items that should be associated with breakfast and milk both can go for bread, and bread can go with eggs. So we created an association with milk, bread, and eggs. So the third one in unsupervised learning is dimension reduction. And dimensionality reduction is a technique of reducing the size of data set by keeping the overall data set in its original form. So all the features that impact very less on the output are either removed or toned down. In reinforced learning, the machine learns to perform a task by trial and error method or trial and trial method, where ML model is rewarded for correct or wanted behavior, and is penalized if the model is going in wrong or unwanted direction. So this was the basic ML category, and this might be enough to choose where the our use case falls. And let's now discuss a few of the AI/ML services. So you can see that the first three are already discussed: the supervised, unsupervised, and reinforced learning. So we start with deep learning. So deep learning is a model developed in order to mimic the way our brain functions, like a neural network. In this, we have multiple interconnected layers. So a deep learning is artificial network that is created similar to our brain. So our brain has interconnected neurons and help us make decisions. A similar network of artificial neural network is created, ANN, and which works in similar manner, which consists of input layer, the middle layer or the hidden layers, and output layer. The fifth category is decision trees. Models working resembles to trees where we have nodes as choices and branches with possible outcomes. Each data is classified until it is predicted with high accuracy and efficiency. So decision trees are used to predict outcome of events or help us in decision making process. So decision tree comprises of root nodes, internal decision nodes, and based on the decision, the leaf nodes contains the result. So now we have a random forest. So random forest is a combination of decision trees that are made like forest with trees and combining their results to create predictions. So random forest collects the results from each tree and expects the final output. So from a so it is like a combination of different outputs from different decision trees to give us a single output. So in naive Bayes, so naive Bayes calculates the probability of an event based on prior knowledge. So let's say we are trying to uh, um, calculate the probability of an object being an apple. So its shape, its color, and its diameter or width will be considered. Though all of these features can have a correlation, but each of them will be considered as an individual feature, and both of and all of those features uh, combined together will be giving us a probability of whether the fruit is an apple or not. So, so the eighth one is a support vector machine. So SVM uses hyperplane to separate information to make distinct classification of data points. So, so let's say if we have data points that are mapped in a 2D plane, an optimal line is used to separate the data points. Let's say we have two class and both of those class are, are mapped on a 2D plane. So there will be there should be an optimal line which would classify both of them separately. So this line is called hyperplane. If so, because we have plotted the data points in a 2D plane, or hyperplane is a line. If we plot our data points in a 3D plane, our hyperplane is going to be a 3D plane. Support vectors are the closest data points to the hyperplane. Going on to the ninth one, the k nearest neighbor. KNN model stores the data and classifies the new incoming data based on the similarity of the available data. So again, if we plot data points on a graph, we can form clusters. If an image or a data point is searched, the cluster where the image belongs to will only be searched in the KNN models. Also, KNN uh, models are non-parametric algorithms. So, non-parametric algorithms does not make any assumption or make the minimum assumption on underlying data, relying on sorting, ranking, and order statistics to extract patterns and insights from data. The 10th one is principal component analysis. And this algorithm is used for reducing the size of the data by recognizing the most important aspect. So PCA is actually a dimension reductionary technique where the data from a higher dimension is plotted to a lower dimension while keeping the originality of the data. So we have also discussed two use cases first before this presentation, which were on Pinterest and Google Street View. So in Pinterest, we discussed about uh, searching the searching similar images or candidate images to the selected image, and how we evaluated the models on so each and every ML model has to first be evaluated whether the performance is uh, up to the point that we want or not. So for evaluation, certain metrics are used. And for evaluating the model, in the case of Pinterest, we used normalized discounted cumulative gain. You will further be will further be discussing that. So evaluation are basically the measurement of the accuracy of the output that we want. In second use case, we discussed about the Google Street View, where we blurred the face and license plates, and further how we decided to blur those. First, we recognize the face and license plates in the images, and further we decided how to will be blurring the selected region. So as as uh, as I said before that offline metrics for evaluation, every model has to be evaluated and after it has been trained for measuring the quality of the output that we have gotten. So these are some of the common evaluation methods. First category is predictive quality metrics. They show how good the model is at predicting the relevant items. So let's say if there is a list of 5 items and we find our relevant item at fourth, and then it is not a good list. We want the relevant item to appear in higher up in the list and most probably first in the list. So this is what the predictive quality metrics measure. In ranking quality metrics, they show how good the model can sort the relevant items and also relevant items to irrelevant items. So there can be a different kind of relevance when we are talking about a list of relevant items. One one relevant item can have more weightage compared to other relevant items. So we can give it as a similar. We can say that it has uh, a particular weight to it or a score to it, which gives it the that particular relevant item more priority over others. And, and those high priority relevant items should be listed further up on the list rather than being down. And irrelevant items should be further down in the list. So first, offline metrics for evaluation is MRR, or a mean reciprocal rank. So mean reciprocal rank considers the first position of the relevant item appearing in the list. So you can see the formula of MRR, where U is the number of list and rank is the position of the first relevant item that is appearing in the list. So let's see the two boxes or images that you can see. So consider that these are the list, and the horizontal green lines are the relevant items that are in the list, and horizontal red lines are the irrelevant items in the list. So so for the simplification purpose, we'll only consider two of these lists, but it will be understandable how to calculate further for a more list. So first, to compute the MRR, we have to compute the reciprocal rank of each list. So the reciprocal rank for first list on the left is 1, and the reciprocal rank on the second list, the you can see that the relevant item appears in the second position. So it will be 1 by 2, and by doing the calculations uh, for uh, for MRR, we can see that we are getting a 0.75. So so MRR is excellent for use of single correct answers, and it is easy to explain how fast a user can find the relevant item and doesn't consider the other items beyond the first one. So as you can see that in the list there were other relevant items as well, but we only considered the first relevant item that appeared on our list, and that was taken into the calculations for the calculation of MRR. So that is the reason when we say that it is an excellent choice for single correct answers. So even if we had other correct answers in the list or relevant items in the list, and they will not be considered for the calculation. So in offline metrics, we have the second metric is a precision at k, where k is the value or the cutoff that we decide to calculate our list on. So you can consider that k is a number of items in the list. So so you can see the formula for precision at k. So number of relevant items in k divided by the total number of items in k. So the overall thought of precision is it gives the correctness of the prediction. So let's see the working of precision first. So you can see that there are in the image that there is a green for similar to the previous one. We have green for relevant items and red for irrelevant items. So if we put down values for k equals to 10, we have total 6 relevant items. So our accuracy becomes 60% when for k equals to 10. But if we take the value of k equals to 5, our accuracy becomes 80%. So the value of k is significant, and while calculating, it should be kept in mind that values of all the list of k should be kept equal. So pros and cons of precision. It should be used when relevant items are large, but user is showed only few items, and it measures how accurate model recommendations are without getting into details of how they are ranked. So, so you can see that we are considering only the number of relevant items that are in the list, but we are not considering how they are appearing in the list, and so that is the reason how they the metric is only measuring only how accurate the model is at recommending relevant items, and not how they are ranked. So for third metric we have recall at k. So recall calculates how many relevant items are appearing in the list of k items for total number of items. So you can see the formula of recall at k, which is number of recommend items at k that are relevant divided by the total number of relevant items. So so let's say that we are taking the value of k at 10, and at k equals to 10 we have 8 total relevant items from 15 total elements. So so if we keep substitute those values, then we for recall at k, k equals to 10, we are getting the value of 0.625. And at recall at 5, we are getting the value of 0.375. So similar to precision, the value of a k is sensitive. But recall solves the problem of precision and is used to check the quality of output list by relevant items. So pros and cons, it works well for topic specific information retrieval. Recall works well with systems with only few or less relevant items and negatively affects the recall if denominator is very high. So let's say we are talking about search engines, then we can have many relevant items and we only showcase only few of those items. So being the denominator and the value of denominator can be very high for such instances, and hence it can negatively affect the way recall will be considered. So moving further, items are compared with every item present in the database, and it is indifferent to order in which the relevant items are shown to user. So similarly, we are still not considering the position at which the items are appearing, and the achievable recall at k varies based on the total number of relevant items in the dataset. If the total number of relevant items is larger than k, you cannot reach the perfect recall. So this is the similar example that I have given for the search engine, uh, and the results being many much to the compared to the value of k. The k is only the value that we are trying to showcase, but there are many values that can be in the data set that could be relevant to the search. And because the value of total relevant items in the entire database is considered, the so the perfect recall cannot be reached, or let's say the measurement cannot be done uh, in an appropriate manner. So now we have a mean average precision. So MAP evaluates all the ranks within the list of top key recommendations. And to compute MAP, you have to compute the average precision of each list. Here the calculation of precision is different to the calculation of precision that we have seen before. So as you can see that we have in the image, we have rank, item, and precision. So the first item being the first is the relevant item. So and it is appearing at 1. So will be considered precision at 1. But the second and third are not relevant items. So their places will be skipped. And and at fourth we find our second relevant item. So so as we are getting the second relevant item at fourth, so first 2 will be divided by the 4, and we'll get zero point 0.5. And for fifth, similar to the previous calculations, we are finding our third relevant items on the fifth position. So now taking the average of precision and calculating precision in this manner, we are getting the value of precision average precision of zero point 0.7 for this list. So let's say we have to calculate for average precision for multiple lists, and how we will calculate mean average precision from that for those lists. So here you can see that there are ranked lists, and each of the average precision is calculated for each of the list. So for first ranked list, we are getting the average precision of 0.33. For us, for rank list 2, we are getting the average precision of 0.75. For rank 3, we are getting the average precision of 0.41. So rank list 2 and 3 also have two relevant items that are appearing. So we are also considering both of them. As in ranked list 2, you can see that the first item is appearing in the first place, but the second item is appearing in the fourth place. So doing the calculation of those values, we are getting the average precision of rank list 2 for 0.75. And if we average the all the average precision for all the four lists, then we get the average precision of 0.37. So this is also a formula for a mean average precision, as you can see in the. So pros and cons. The metric is sensitive to ranking. So we are considering the rank this time, and so as you can see, there are different places in the list where the relevant item is appearing. So this time, the way the items are appearing is also considered in the calculations. MAP focuses more on getting the top results right. So if let's say that the item is appearing in the last position or the fifth position, it will have a different calculation. It will have a lower number. So that is the reason it heavily penalizes the system for. Sorry, it. So the calculation of the last will be lesser than the calculation of the first elements. So MAP heavily penalizes the system for early errors. If getting the top predictions is right is essential, MAP is a valuable metric to consider. This makes it a popular choice for information retrieval tasks, where you want the user to be able to find the relevant documents quickly. So one of the reasons that we are that we are doing is we are only considering whether the item is relevant or not relevant, but we can also have the relevance scores, as we have discussed in the ranking quality matrix. So so you can see an image down below where a list which is based on similarity score or a graded score would look like. So if we are trying to find an image of a dog, then depending on the image, we will have a similarity score. So the fifth being an exact match to a dog is getting 5. Fourth being somewhat being an exact being a good match, and two just for 2, 1, and 0 are not much of a good similarity score. So let's see the calculations for graded or similarity scores, or consisting output lists. So the fifth is the normalized discounted cumulative gain. The formula of NDCG is equals to DCG, or discounted cumulative gain, divided by ideal discounted cumulative gain. So discounted cumulative gain is the output that would be given by the model, and ideal discounted gain would be the order in which the output should have been, or we want the output to be. So NDCG is calculated for graded relevance and binary relevance. Calculating the NDCG has three steps: compute the DCG, or a discounted cumulative gain, compute the ideal discounted cumulative gain, and divide the DCG by DCG. So, calculation of normalized discounted cumulative gain by a graded or similarity score. So you can see that we have an output list which is produced by the machine learning algorithm, and these are the scores that we have given to it, depending on the search of the similar image. So here we are searching images that are similar to dog. So and that is why the scores are given in that manner. And in order the order is produced by the ML model. So if we input those values in the formula for DC discounted cumulative gain, we get the value of 6.151, and we compute the DCG for the output list that we would have wanted, or we want the output to be like. So second is the computing the ideal discounted cumulative gain, and in that order we substitute those values in the formula, and we get the value of 8.9. And by dividing the value of discounted cumulative gain with ideal discounted cumulative gain, we are getting the value of 0.6869. So the values of NDCG will always be lying between 0 to 1, and closer to 1 will get more is considered to be more accurate. If the IDCG and DCG is if DCG and IDCG is divided and we get 1, that means it's a perfect output list. Though while training the model early in an early stage, it is not it is a rare sight to have. Now, we have as we have calculated the NDCG for graded or similarity scores. This is the calculation of normalized discounted gain for binary relevance, or 1 or 0, whether the item is relevant or not relevant. Relevant 1, not relevant 0. So, the, so you can see that the first horizontal list is the list provided by the ML model, and the second list is the list that is provided by that is the list that we want. So we are having total three relevant items in the in the list, in both of the list, but in the second list we have just rearranged those items. Now we're computing the DCG, and by going by the formula of DCG and substituting those values, we get the value of 2, and by computing the IDCG we get the value of 2.1, and we are getting the NDCG of 0.95. So value of NDCG, as I stated before, lies between 0 to 1. 0 having no relevance to the in the list, to 1 being equal to the ideal ranking. The higher, the better. So pros and cons of a normalized discounted cumulative gain is weighs higher items at higher positions, works with binary as well as numeral scores, as we have calculated the normalized discounted cumulative gain for both relevant relevant scores or graded and graded scores, relevance being 0 1, and graded scores between 0 to 5, and depending on the similarity the scores are given to the images or the result. So disadvantage of NDCG is it needs relevant scores and similarity scores or graded scores labeled to work with. So, so we have we so when we calculated these lists, we already had the ground truth relevance scores with us, but it is not possible to have the ground truth relevance scores every time, especially when new incoming data is coming. So this is one of the setbacks of, or should be one of the important points that should be considered when we use a NDCG or a normalized discounted cumulative gain. So in our use case in Pinterest, we discussed about NDCG, and we NDCG also, and we chose NDCG for offline metric evaluation. And because in Pinterest we were trying to search an image and that is similar to uh, search images that is similar to a one selected image. So as you can see in the image below that we have searched for yellow flowers, and you can see that there are few of them in the list that has yellow flowers in it. And the other thing why we chose a normalized discounted cumulative gain is because of its ranking quality. It considered how the relevant items are appearing in the list, and that is what we wanted. We wanted uh, the more relevant items appearing higher up in the list, and irrelevant items being down the list or not appearing at all, if possible. So in the use case of Pinterest, we also discussed why MRR, precision, and recall are were not used. So MRR, precision, and recall all ignored relevance to the order in which the items appear in the output list, and in mean average precision it considers the position and quality, but is for a binary relevance. So as you can see that as you remember, if I can in mean average precision, we are only dealing with binary relevance. So whether the item was relevant or not, and not with similarity score or graded score. So this is the reason. This was one of the reason that we didn't use mean average precision at the time of discussing Pinterest's use case. So, so other use case was Google Street View, the way object detected models. So we use we discussed about a technique of intersection over union, where models intersection over the actual detections or actual objects should be more, which is simply called intersection over union, and that should be uh, calculated. So as you can see in the image that there are total three objects, and the model is trying to make a total six detections. Uh, Two of them have IOU of 0, means they are not on any of the objects. Some of them having IOU of 0.13 to 0.85. The IOU of zero point 0.7 and 0.85 are really good and can be considered as a good detections. So, as the model was making predictions, we discussed about the metrics of precision, average precision, and MAP. But we decided to go with average precision and mean average precision. So average precision was was selected to measure the measure the overall detections made by the model on single class. So let's say a uh, model is trying to guess two shapes in the image. One is circle, one is square. So all the detections that will be made by the model to detect circle will be will be calculated using average precision, and all the detections that would be used by the model to detect square will be separately uh, uh, calculated for the average precision of square. And for the model's overall performance, the mean average precision will be calculated. So yeah, this is the whole presentation of the models, as well as discussing their offline metrics for evaluation purposes in the offline manner. These are some of the references that are either used for used in this presentation, or can be used to further deep dive into the topic. So thanks a lot for listening. Thank you.
Thanks, Jaymeet, and we open the floor for questions. Go ahead, Preetida, Amina, and Nilesh, and whoever is there. If you have any questions, please go ahead. Who wants to take first?
Hello.
Yes. Yeah, Preetida.
I'm yes. Good evening to you, all. This is because I was not present in earlier sessions and things. So this I presume, and I from beginning the slide you already said that this is a system design, ML system design continuation from the first lecture or first presentation onwards. I just want to know that do because you place some of the mathematical equations as well as the you also presented some models and things like that. Is there any particular agenda over here that says that step by step the how this lecture series will go on?
Yeah, at this time, we just digress from the use cases just to make sure that the whatever was asked by Mumta and your people to get the exact models and their what you call algorithms. So we actually had a plan to go use case by use case, but we after two use cases we brought back the first one and then tried to go a little bit deeper in model so that you can deep dive model. So example, next we are going to continue with ML system design for YouTube videos. So we have an order in which we are going. At this time, we want to just focus mainly on the image and object recognition and not go into the text and all that time being. But at certain point of time, at halfway, probably fifth one, after that we may choose to go more on the like GAN or maybe the OpenAI and those kinds of large language model, NLP, and those things. So
Okay.
at this time, we are focused mainly on the image, object recognition, video, and more with the what you call graphic and image and video streaming data.
Mm-hmm. Yeah, I was just wondering. That means if you insert, this is just a simple suggestion. If you want to
Mhm.
consider or not, I don't
Sure,
know.
sure.
It would be nice if there is one particular presentation relevant. So people already say, "Oh, I'm doing modeling using the uh, machine
TNF.
learning
Mhm.
algorithms and things like." But what you need to consider prior to finally going for the modeling, that feature selections and things like that. Uh, we already had some discussion about the uh, uh,
Correct.
over
So,
mapping and all these things last week. So,
mhm.
is there any particular discussion happened earlier or something?
So what we had done was initially when we started, we went with the total pipeline. What is the
Yeah, so that
evaluation pipeline?
pipeline, that particular model design pipeline has been finished, or it is.
No, 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 no. So we started with the first one. So I think I would do one thing. These are no more than 45 to 50 minutes, not very long ones.
Mm-hmm.
So
Mm.
what you can do is we have one, two, three. All of them are already uh, updated on the. If you can go through first one, second one, third one, and then you look at this. This is like trying to bridge the gap between one, two, three, and trying to explain. Now, more what you are asking is augmentation, right? We did discuss some augmentation, but not really deep dive and
Yeah, just I'm asking that overfitting and underfitting and all these
correct,
things.
correct, correct. No,
So all
we
these
need to do
particular very these are very small
relevant.
aspects. These are very
Correct,
playing important role for model design
correct.
uh, in prior. So
So what I would suggest, people go ahead and ask some. If you have any specific on overfitting, underfitting, you would like to hear from us, we can approach. We have Professor Gokhale, who is also an expert in that, and we have Sayam Pathak. We have other group members who I can. So you, if you have a list of things that you want to see in the course or in the study, certainly we don't call it course. Actually, it's a studies. Somebody studies, somebody presents. If you want to study something, you want to present, most welcome. Or if you want some experts to present, you say this is the topic I want to hear from something, and we go deep dive into it and do it. So at
yeah,
this time,
I just because the thing is that because you have already started something with your objectives that I saw on your page that you already mentioned. So I thought actually let me give a little bit background of who am I or something
correct,
like that.
correct, sure, good.
I already had industry and academic experience,
Mhm.
and last year I left from institute because I wanted to start my own
Startup.
venture in terms of this AI only.
Mhm.
So what I say, because I was also teaching this subject since last 5 years
Mhm.
in Mumbai University affiliated institute, and
Mhm.
that's why I just thought that what actually particular when we teach this subject, what actually is missing, you know,
Mhm.
because there are so many algorithms. We just say, okay, you use this algorithm for classification, you use this algorithm for regression, but why we have to choose these things? Why we need to choose only regression, not classification? So there is no possibility of a regression over here, so we can just make a classification. But that is not the only answer. No, technically we should know.
Mhm.
Implementation point of view, students, they just get that particular view. Okay, we know now do the coding here, but that some strong foundation is very much required, and that is what I feel that is what is a missing link when we deliver these things to the student also. So if the working group, your this group is already having these experts, then it would be nice, because that will already give some ideas to the people who are already maybe already involved in some venture, or going to be going to part of the industry and things like that. So that
Mhm.
will help. That is what my intention, because if you make it more practical, no, then it would
Mhm.
be very helpful.
Okay. Perfect, perfect. I think so.
So because
Let me.
this particular is not, this particular subject is not only for having some theory, but simultaneously, if we make it more practical view of all these things, then it would be very helpful, because that is a main thing is missing when you see all these particular classes who are running open, in open mode, as well as in just Edureka and all these things. They don't have enough time to deliver because they teach online. But when you have a sufficient time, you have dedicated some 1 hour or 1.5 hour every week or something like that. So that gives us something, people to how to be more practical, become more practical oriented with this theory rather than digesting only theory.
Correct, correct. See, that is where we were focused mainly on the use case. But to explain the use case, we found we need some theory to explain. So
Yeah, that I
that's
agree. That I fully agree. But
so yeah. That is.
some
Mhm,
aspect should be already involved with theory also, practical aspect also. That is what I'm
mhm.
just saying. So,
Yeah.
just
So
like
give me,
you,
give me, give me, Preeti, where were you here in Mumbai?
I
Which
work in
college?
Sardar Patel Institute of Technology in
SP,
Bhawan.
SP, SP Institute. Yeah, I remember. We had interacted with SPI last year. In fact, this year. No, no, not this year. This is 24, right?
I
23
think,
March, we were going to do something. And there is one new professor who is coming from a startup, I think. He took over the AI stuff. And we were planning for March at that time, but it didn't happen because of Professor Gokhale, who is here from Mumbai, who was,
yeah, I know Professor Gokhale, and because
yeah,
he already came to my institute at that time, last year or before COVID. I don't remember exactly, but I know that thing. And I was not very much involved with this all this meet group, even though I was a member and things like that. But sir, somehow I saw your particular
mhm.
invitation, and then I came across the same
So
area
currently,
where I'm working and things.
so
So then I
currently
thought
you
that
are
I
in
could take some
Gujarat.
interest.
Currently, are you in Vadodara with the startup, or is it in
Yes,
the?
yes. Currently, I have come because I had some discussion. I came for some meeting over here, and tomorrow morning I'm leaving. So,
But you'll be coming to back to Bombay. Are you still in Bombay, or is it?
yeah, I'm still in Bombay. I'm still in
So
Bombay.
where are you located? I am in Chembur, and Gokhale is in Navi Mumbai. So both of us are in this area,
Yeah,
and
I
we
have
sit.
office in Andheri also, but then normally I
Okay.
work from my home. I live in Nalasopara,
No, no.
so
Oh, that is good.
I
That.
work from home.
Uh-huh. Okay. Okay. No
I
problem.
If I have something, then I go to office that is located in Andheri.
So what we can do is once you are here, over the coming weeks, sometimes when you are here, we can meet with you and go over what startup, what do you want to do, how we can help you, and how
Mm.
the education system should change actually. Because it needs to change. There is no doubt about it. Just throwing some theory doesn't solve the problem. And you have to go the problem way. If this is the problem, how do I improve the accuracy? How do I improve the precision? What do I need to do to reduce the data? How can I do? Because some of the things are applicable to edge also. It's not that you do have a cloud and you have a GPU and all kinds of resources, right?
Hmm.
So, so how do you optimize for a, and there are some model exchange, transfer learning, right? In transfer learning, you got to have some kind of a, what they call as ONNX, Onyx. So you can have a runtime transferred along with the uh, data so that it can be utilized to speed up the uh, what do you call the uh, inferencing and all that. So there are methods used commercially which I'm aware of, and Professor Gokhale and me have worked together, and we can actually bring what you are requiring. But you should give us a little bit more background what exactly you want us to do. We can actually narrow focus on
Yeah,
on what.
I'll send you an email if you have an
Yeah,
email. I'll
yeah,
send you a
yeah,
few things so that
yeah.
you.
So
So no.
you can send me at pramchan@utf.in. Mhm.
So you are located in Baroda.
No. I'm located in Mumbai.
Okay, okay. Uh-huh.
See, I come to Baroda because I used to study there long back. So that is my association with Mamta ji, uh, and plus my master's was here at IIT Bombay.
Okay,
So
okay.
I'm located in Mumbai only for the time being, and Gokhale is gone out, so he's coming back 25th or 26th. So maybe
Hmm.
somewhere in the month end we'll be able to come together and meet you. If you are coming to SP or if you want to meet at Andheri, whichever place you want, you can come down and then go there. Because for us, Andheri is a better place because we can take a metro from here from Ghatkopar. As
Uh-huh.
well as,
I'm not
and,
sure if if you are in March 23rd or something like that you are talking, no? Perhaps
um,
I'm at
no,
that
no,
time.
March, not March 23. This is January, right? January end now.
Oh, January 23rd.
Yeah.
I'm leaving for tomorrow. I'm going Delhi.
Uh-huh.
So I won't be back till the
No,
end
no
of
problem.
the. Huh.
So we can meet at because we also have
Yeah, yeah,
work in Delhi and all we do.
yeah.
So this is national, right? We are doing it national level. We do here
Hmm.
Chennai, Pune. I'm going Pune to do something day after 23rd or 24th. So
Okay.
and Gokhale comes on 20. So we are traveling most of the time, like you are,
Huh.
right?
Hmm.
See, this is the situation. That's why we are preferring this doing over the web, right? And Geo, because we also believe in the Make in India, so we try as much as possible to use
Hmm.
Indian stuff. Geo Me, Geo Pro,
Yeah, there
Geo
should
Event.
be some uh, Indian way to see this particular technology because
Yeah, yeah.
I
So
fully agree
what
in that sense.
So what we'll do is we'll definitely work with you. Let's give some time while we
Hmm.
continue. So you ask for more on the how do we do for augmentation and what effects and how we can like priorities he has said.
Yeah,
Okay,
so prior to building a model, what things you need to see,
yes,
you see, uh,
exactly,
with a given data set, and even if you are
correct,
creating some synthetic data, what is importance when you are having this GAN model and all these things.
correct. Yeah, that's true.
Yeah.
So GAN model and you see, this is where the use case is very important.
No, it is just not so useful because why you choose this SVM, why you choose this regression, why you
Correct,
choose
correct.
the classification. So prior to
Okay.
that, all these features that you already have, that
Mhm.
feature engineering becomes just like a nowadays where LLM people talk about the prompt. So
Correct.
prompt engineering. So that is
Prompt
after the
engineering.
model has been developed, but before the
Correct.
model you develop, you must have some insight, and there is some overlapping between the data science, data
Mhm.
analytics, and machine learning over here.
Correct, correct. That's true.
So
That's
that
true.
is why.
So, see the like all these GPT 3.3.5, 4, all these were developed over a period of time, and
Hmm.
I can bring one guy to present Pratik Desai, or somebody who's got a Kisan AI. I can ask him to present and say what he faced. Like he started with OpenAI, and then Azure, and then he dumped it, and he went into some new AI, and then he's making API for India now for Kisan information. So he is out of Surat. So I can ask him to present something, what he faced and how he faced. So real life challenges, what is, because he's a PhD in this. So
Hmm.
maybe I can ask him to present, right? So if you want something of that kind, you source the people.
Yeah,
And
once your group gets expanded,
Mhm.
that will be helpful. That is what I
Sure.
see because I do work on some projects and things like that, and when I interview students and see, I feel that this is something missing link when we already teach students and what they
Mhm.
grasp, because most of the things that student they grasp from the programming point of view, you see.
Correct. Correct.
So the programming point of view, anyone can do the programming if they are creative in doing programming and things
Correct.
like that. But
Insights.
you need to
Insights
have
is important.
this thing
So that
there.
is why insights comes only if you have implemented, deployed, and serviced, and then uh, bottom up. That is from the ground. If you started, envisaging the hypothesis to the modeling tool, then only you will be able to do that. And just uh, what you call a reading of the book and just that will not be sufficient.
Yes, exactly. So that is what I just wanted to, because people do take interest because it's a new technology, and they say it is not the only engineering background is that there is so many things are there, because there are
Correct.
multiple domains are there.
Yeah.
That is what I really feel, because for current generation of the student, this has come like a boom. So when they do not have very good mathematical background and things like that, this they think, okay, I just have to do programming, I know Python, I can do these things. So but simultaneously it is equal important to have a very good foundation of the maths as well as data science and things like that to
Okay.
dive, if you really want to see from the learning and good understanding of this technology.
Correct. Correct. That's why we went into deep dive, and we'll go into augmentation and other things, because we are not just going to go straight forward. That's why I did not define anything. I said we'll just go by some use cases, and as we go, we will adopt to the requirement. And this is good that you give us feedback. We will try align that what you are asking for. Like somebody has to know enough of several algorithms to say this
Yeah,
does this,
yeah,
does
yeah,
this, and therefore you should use this, I use this, and this is how you should do it. Okay. So
exactly.
that comes from. I'll ask. There are at least 4 people in our group who can go. Clay himself is there. Then you have Sayam, who did work for what they call a big company. What is that? That does the mm, sales and all, online marketing, online sales and all.
Hmm.
Similarly, Walmart, there is one guy. So there are people
If there is
who.
someone from engineering background and actually developing some engineering product, no, that will be very helpful. If
Okay.
it is a, if this group is already part of the MS University engineering group,
Mhm.
engineering department, then if there is someone from the engineering, because why I'm saying, I taught this subject for 5 years.
Mhm.
Last 5 years, I was teaching this data science, machine learning, deep learning, and all these things.
Mhm.
So then teaching is no problem, but to make a simultaneously to realize what is the practicality of this work,
Mhm.
it is very difficult, and that is the main thing is lacking
Yes.
in most of the lectures. You see, that
Absolutely,
is
you're on dot. See, this is where we started this. Even though we said, okay, this AIML, everybody talk, but where is the understand inside?
yes, exactly, yeah.
So what we said is let us group. See, we do have an AIML group besides
Hmm.
this study circle. We focused on study circle so that we can study and each one presents the case and then come up with something. So at this time we have only defined for 10, saying that let's do it for 10, and if we find that it picks up, we will add more. So like now I have SIT Pune asking for it. I have what do you call the CDAC. So uh, then we have Ramanujan College, Delhi. So I have a lot of colleges who are interested in developing skill set to enable the practical implementation.
Hmm.
So
Hmm.
and MSU is one of them. So we have plenty, and that is why we are also going to organize a workshop like 2 hours each. University focuses on certain area and then provide. But so each one has a different focus, right?
Yeah,
There
yeah.
is so many things in AI. I don't know where to start. They talk about quantum, QML. So there is a quantum machine learning. That is another.
Yeah, if you want to have someone from the quantum machine learning, I have a very good contact,
Mhm.
a retired scientist from the BARC,
Okay.
and very soon the FDP is going to be conducted in a NITs by him. So I can bring him also. You can see
Sure.
that also, because he's
So
already working on QML and all these things,
okay. So
quantum
uh,
computation. Yeah.
yeah. So quantum machine learning QML, uh, and this is NIIT or ND. What is the institute you say?
Sorry.
And you mentioned some institute name, right?
Yeah, I know the person who is a scientist who used to work in a nuclear technology in BARC, Mumbai.
Oh, okay, okay. So you are
So
talking
now,
about BRC. Yeah, okay. That,
Baba Atomic Research
yeah, yeah,
Center, and
BRC.
then
Okay.
after that he has retired and he's
Yeah, we can.
located in Calcutta, but he is still doing work in a quantum machine learning,
Yeah.
because I already
Mhm,
coordinated projects with him when I was in SPIT for final year
mhm,
projects, and
mhm.
he had a very good
Deep insight.
rapport with this particular new technology and guiding the students very well for the new thing. So
Yeah,
if
bring him in. Bring him in. We can ask him to even present.
yeah, yeah,
Dude, go ahead. See, you can act on behalf of this is a study circle. All of us are learning, and all of us are also providing inputs to each other.
mhm.
It's a circle, right? So
Yeah,
whoever that professor is, you ask them that would you like to present something specific, and we are definitely going to uh, present it. Ask him when he's ready, what he wants to do, what is his agenda, what he wants, and we'll include that.
yeah, I'll
And
ask him.
this is early stage because we have not even dug the
Yeah,
what is called.
because now most of the things at the QML is going very fast, and I think still people, we don't have any subject in any university relevant to it.
QML apart, even quantum computing itself is not there. So we have myself and Professor Gokhale, we put a dozen uh, videos in our EOTF channel for
Huh.
quantum.
Huh.
So we have already not dozen, 18 actually. It was
Yeah, but
18.
IBM already provides
Yeah, IBM provides you
facility
only
for
the
that.
no, IBM provides you the kit, right?
No,
But then
no,
you have
you
to,
can do the online work with them.
yeah, you can do online work, but somebody
Hmm.
has to show you how to do it, right?
Yeah, there is already a very user-friendly web page they have,
Yeah, yeah,
and
no, no,
huh,
here.
and you can taste your algorithms, quantum algorithms, and things over that. So,
Yeah, so we have done that for the, what do you call the, uh, some of the standard algorithms like Shor's,
hmm,
Grover's, and
hmm,
then Deutsch. We have
hmm,
presented. So we have gone through 18 weeks of presentation
hmm,
last year.
hmm, hmm, hmm.
So we have used the IBM quiz kit and we have borrowed from that what they were giving, but they are so rapidly changing that you cannot even keep pace with them.
Yeah, yeah. To keep a pace, it is very difficult.
So what we did was we only used up to certain point, and then we found they have already changed the APIs and changed the naming, and so we said that at this time we want to end up with what we had. We did
Hmm.
not go proceed, and we have contacts in IBM. Like there is LV Subramaniam in Delhi. I can ask him to present, but our objective is not get stuck by one of these IBMs or Google's. Google also has a kit or DWave has a kit, all these commercial kits, but we want to see what can we do Indian nights and for Indian
That's
application. So that
yeah.
is why we are bit, whenever we talk about IBM and all that, okay, IBM, if I tell them they'll only bring quiz kit and keep on talking about quiz kit, but what is it relevant to me? How do I use it? Right? So
Yes,
what
yes.
we have done is
Hmm.
we want an Indianized tool set. That is
Hmm.
what we are trying. So study circle will grow as we go, and
Hmm.
this is now our existence for fourth or fifth year now.
Hmm.
So
Hmm.
it's not like we started yesterday, but AI ML focus we brought in only
Hmm.
last year end. We completed the quantum focus last year. Prior to that, we had done digital transformation. We have worked with NIC. We also did a, FDP and all that
Hmm. Hmm.
for NIC that we started in 19. So we
Hmm.
have done
Hmm.
19, 20, 21. We have done multiple FDC. Also, we
Hmm.
have worked with the OpenStack Foundation, the Linux Foundation,
Hmm. Hmm.
Akranos, and Akimo. What is that? AT&T. So we have
Hmm.
worked with all of this. But idea is, what can we do? Developing skill set for our local people.
Yeah, so some indigenous way to
Correct.
divert this particular technology. That's
Correct.
very essential. Yeah.
So I think
Because
you are
the software engineering software is going to there will be no need of the software engineers after 10 or 15 years, because that
data.
is it is open AI and chat GPT has already made these positions already obsolete. So how we make our engineers to have some type of innovative ideas and do these things. So that
Perfect.
is very, and that has come that has to come indigenously, not from. And it
Yeah.
is now, the programming language is not a Python or R or whatever we say. The programming language is now English.
Yes.
Because when you do the
No, no, not just
prompt
English.
engineering, you speak in
No,
English and you get the code ready for you. So
no, no.
now
One sec,
I don't
sec.
say programming language is now any language like Python or Fortran or whatever we
No,
studied
no,
and
no.
things.
Okay,
It is
okay,
only
okay.
English. English is the only language now
No,
for
no, no.
computer also.
I would say it is not English. They are doing it in Gujarati. They are doing it in Hindi. They are, NLP is allowing us to do in everything. Government of India has already invested enough. In fact, the Kisan
Hmm.
GPT is the one which I am talking. It's not English alone. It is Hindi. It is also available in multiple languages, around 8 or 9 languages. So it has gone way beyond what we think.
Yeah,
And
that's it. But it has to come in a practice, na? Unless and
yeah,
until
practice. No, no, they are.
exactly.
That's what I tell you. Kisan GPT. You will be take a look at Kisan AI,
Hmm.
KISAN Kisan AI, and then you will see it's a T2D or something. T2D.com. T2D.com, and it is Kisan AI. If you look at Kisan AI, you will find that there is a lot of development there, and
Hmm.
they are Indian based, and they have proposed to government and the United Nations. UNDP has given them the go for also going for African and all. So
Hmm.
it is not just English. It is English and Hindi are main because they get more in India. Hindi gets more preference, but not
Hmm.
necessary. There are other people all over. Tamil is one which is also moving. Then Gujarati is one
Hmm.
which is moving. Then there are Marathi ones. So there are many. It is all regional. Like you cannot go to a Kisan and ask him, "You speak English, right?"
Yeah, that is very right. But that has to come as a part of, because there is, if there's something like a Chat GPT today, there is a, now they don't call the LLM model, they call it LAM model, large action model now.
Yeah. Yeah. So they see
So that is,
adaptation and
uh,
innovation will keep
uh,
occurring, and
so
you are
large
going to get
action models are there. So that is why I'm just thinking that it has to come, this all applications or whatever it has to come at the indigenous level, then only it will be
correct.
useful with a
Correct.
large mass or
In fact, that is where the issue is right now. People don't believe that we have to use OpenAI. They want
yeah.
their own. So each vertical is trying to define their own uh, lexical terminology uh, and the what you call the terminology that will be used for the AI model.
Hmm.
So it is going to be quite a long journey. I don't think it will happen in year two. It will take few years. So we are at the beginning of the evolution here, at least in India. Okay, I think
Yes.
I will stop here. People are waiting. Is there
Yeah.
anybody wants to ask questions? Amina, Jaymeet, or Nilesh, or anybody? You have been listening to the conversation between me and Krishna. Anything you have? Okay, looks like anybody? Anything? Jaymeet, you there?
Yeah, sir, I'm there. I
So
was
did
listening to both of you. That's the reason I muted my mic.
okay, okay, no problem. So Amina, you have anything? Or we can Nilesh, we can. In that case, we'll close down and
Yeah.
we will take the inputs from Kritika, what she wants to have in the next, and if we get it, then we can include that in the YouTube videos for augmentations and all that. Whatever. If you can include that, that will be super. But
Yeah.
later, you just send me a mail, okay? pramchan@youtube.in, and then we'll try and include that. I will speak to all the experts who are there with me at least. And if you have connection, then you can also bring in and we can ask them to support. Okay.
Yeah.
So, Jamie, Amina, Pritira, Nilesh, everyone, I think we'll call it a day. It's almost coming to 7:30, 1.5 hours, which is the target. We are 7 minutes less. We are getting out, but at least we had good discussion. Especially Pritira's discussions were very fruitful. and let's hope that she has taken the bold step of doing startup. So let's hope she can turn it around and succeed in that. And we'll support you all. Okay. Thanks a lot. I'm going to end the
Thank
recording.
you.
Yeah.